Hello everyone, this is Ali Karimi talking, and today I'm gonna explain to you guys the 26th learning outcome or topic you need to know for histology. It's called endochondral and intermembranous ossification. Let's dive into it, guys. There are three general info I need to explain to you guys before we dive into the topics, and those are these three. First of all, what is ossification? Ossification is a process of bone formation and eventually its growth. Okay? Every time when there is either of the two methods, intermembranous or endochondral ossification, is for bone formation, yes. But first of all, they will create a primary bone or a woven bone, which later on becomes replaced by a lamellar structures and become eventually a secondary bone, which is a lamellar bone structure. And how it works. Basically, the osteoblasts start producing osteoid. The osteoid get classified, and that classified osteoid become osteon, which is the primary structure and cell of the bone. Okay. Next thing we need to talk about, intermembranous ossification. I know it's too many wording in this page, but that's for those people who want to even go into too much details. The way you need to explain these two processes is like a story-wise, and you can remember this picture for it in order to properly explain these two. So for intermembranous ossification, the first primary cell from the mesoderm, we have mesenchymal cells. Mesenchymal cells will differentiate into osteoprogenitor cells, and osteoprogenitor cells makes up the osteoblasts. The osteoblasts will go to the location that the bone needs to be built and will start immediately producing that bone. In contrast, the endochondral ossification, first of all, needs a cartilaginous sort of model of the future bone, and that cartilaginous model will eventually get ossified and become the bone in the endochondral method. But now, let's go back to the intermembranous ossification. So we already mentioned what osteoblasts will do. For example, not for example, but mostly the osteoblast in the intermembranous ossification, they're gonna make the flat bones, and they're gonna make bones which are flat for calvaria, which is on your skull, and also 2/3 of your clavicle. It's also gonna be formed by intermembranous ossification. Now, other things we need to mention is that the osteoblast will go to that area, start in a circularized way, and producing osteoid around itself. But that area that is producing, it will be called primary ossification center, okay? Because ossification is happening on the osteoids. And the place that osteoblast is present, it will be called specules, okay? Awesome. Now, when these osteoblasts are producing in a circularized way these osteons, they get trapped into it. And after getting trapped, their name will be changed into osteocytes. Osteocytes, they will communicate with each other through lacunas. Okay? Eventually, each of these osteoblasts, they create their own ossification center, and these ossification center eventually connect to each other and fuse to each other, becoming the primary bone or a woven bone. These woven bones later on go through by when the blood vessels and everything come in that area, they go through a process of lamellarization, and they get replaced by lamellar structures. Okay. Now, at the periphery of this future bone, the osteoblasts will create periosteum, the outer part of the bone, and endosteum, the inside part of the bone. And that is everything you guys need to know for intermembranous ossification. So you need to explain it like a story, guys. It's how you will do, because other than that, you need to memorize all these steps, and it will be so difficult, literally, to just go, okay, I already said the first choice, the second one, third one, till the eighth. It will be boring. If you give it like a story, like how I gave it right now, it will be, first of all, much more interesting for yourself and the professor who is asking you the question. Now, intermembranous ossification, this is a slide you will get. It's called A14. And as you can see here, guys, it's a speckles. Speckles means that the osteoblast is present in that area. As you can see here, it's around. And the osteoblasts that have got trapped in their own creation, the osteoid, they have changed their name now to osteocyte, and they are in these speckles, okay? Now, around it, you can find some mesenchymal cells, and also you can see these big one here, that's osteoclast. It's resorbing the bone, and in their place, a lamellar structure will be created again by osteoblasts. At periphery, we can see periosteum, and that's it. There's a vessel here as well, but that's how you know that the woven bone has already been created. And by the presence of vessels, it's sort of our cue that, okay, osteoclasts are resorbing that area, and osteoblasts are making that area more lamellarized. Okay? This is another view of the picture I showed you guys. Here we can see like hair follicles and things like that as well. That will cause for us to think that probably here is like part of the calvaria or your skull, because there's hair cells there, the bone is being created, and as we can see, it's not like there's no cartilage in this area, so it's probably intramembranous ossification. Therefore, it probably could be the skull. Same structure as the other slide is present here, so we can move on. This is a more zoomed in picture. Good thing of this picture is you can see now the osteoblast that have got trapped in its own creation and become osteocytes. Okay? You can see osteoid here, all this red one, and here is osteoblast. We see osteoclast, which is like bigger than the osteoblasts and is resorbing there, and there's mesenchymal cells there too. Next thing, we go to the next part, and next part is called endochondral ossification. It has a few steps more than intramembranous ossification, but again, guys, just remember this picture here, and you should be fine. So how are you going to explain it? Simply, you need to start from the beginning, the mesenchymal cells. Mesenchymal cells could come from any of the three germ layers, mostly from mesoderm in this case. And the mesenchymal cells will give up the chondroblasts. Chondroblasts will make cartilages, usually hyaline cartilage, and or chondrocyte, which are becoming hyaline cartilage. And eventually, after these hyaline cartilages are formed, they form the sort of a cartilaginous model of a future bone. Then, as we can see here, a small circular bone collar gets produced around it in the diaphysis, not in the diaphysis, around the diaphysis. And it will cause a sort of ischemia to happen in the middle. That is a cue that for other arteries, nutritional artery, to come with their osteoclasts, make or drill their whole way through this bone collar and go to the middle of this bone. And in there, they will start the process of a place called the primary ossification center, meaning that the osteoclasts and chondroclasts are destroying those ischemic chondrocytes or hyaline cartilage, which did not have enough nutrition. They're getting destroyed, and in their place, osteoblasts are starting to make the bone. Okay? Now, beside this, we can also see that after a while, another artery, another nutritional artery, goes in the epiphyseal part. And in the epiphyseal part, this is will starting the secondary ossification center. Okay, so here in the middle, in the diaphysis, there is a primary ossification with its nutritional artery. It's making its own bone, and on the proximal and distal part of the bone, which the epiphysis is there, it's making its own ossification center, secondary ossification center. It has its own arterial supply. Now, by the time that this bone is created, most of the hyaline is gone, with the exception of two different places. First of all, will be the articulating cartilages, which will be the surface of the proximal and distal part of the bone. And secondly, there will be the is sort of a line separating the diaphysis and epiphysis called the epiphyseal plate, which the hyaline cartilage will remain there. Why it will remain there? Simply because it needs to help with the longitudinal growth of the bone, meaning that it's going to get longer from both sides, from this side and from that side. And I'll explain the difference between the longitudinal and another type of growth, which is called appositional growth. Appositional growth means widening of the bone. So that will happen in later stages when the baby or the child is growing, and therefore the bone needs to grow as well. But so far, what I explained right now, this is everything you need to know for literally endochondral ossification. The only thing I think I missed that will be same as the intermembranous ossification, this time even more, at the place where we had the bone collar, the osteoblast will differentiate and becomes periosteum, and periosteum will have its own artery as well. So we can move to the next topic. Next topic, before we go there, let's look at some slides. This is endochondral ossification. We can see hyaline cartilage, line of erosion, speckles being produced by the osteoblasts, and also osteoclasts in this area have destroyed that hyaline cartilage, so osteoblasts are making the bone there. Similarly, actually better than that picture, we can see here how bone collar was here. This is hyaline cartilage getting degenerated in this area. And we can see how the bone speckles is coming here, the process of ossification and so forth. And here we can see the bone marrow. Same in this picture. This big, huge cell, it's going to be osteoclast, definitely classified cartilage and so forth. Pay attention to the staining, guys. Here it's H&E. Here is azan. For the reasons I'm sure you probably know already. Now, next slide. Again, it's close to what we had on the other slide, with the difference that it has been more zoomed in. And I thought it will be a good explanation for you guys to see different slides of the same topic we're talking about. Now, I think I did not. Okay, yeah. So let's go back here, guys. Here, I need to also explain to you longitudinal growth. Longitudinal growth, guys, I mentioned it briefly. I'll explain a bit more. In this hyaline or hyaline cartilage area or epiphyseal plate, the hyaline cartilage will go into, like, it will get bigger, and the older ones will get ischemic, so osteoclast and chondroclast will go in that area, destroy them, but in their place, the new osteoblasts are making new bones, while still ahead of them, there is still another hyaline cartilage present. And so that hyaline cartilage produce more, its older cells starts to get older again, ischemic, same process happens. So it will build up to this side, and the other part will build up to that side. So distally and proximally, the bone will get longer. On the other hand, around the diaphysis especially, the periosteum will have its own version of artery and osteoblasts, and they will sort of help with widening of the bone, and with the same process start widening the bone as at the same time when the longitudinal growth is taking place. Widening of the bone, it's called appositional growth, guys. So yeah, that's another thing I need to mention. We already go through the slides. Let's go through the stages of longitudinal bone growth. So I explained to you guys that first of all, the hyaline cartilage is there. It gets more, so more hyaline cartilage gets produced in that area. They go through some phases to become ischemic, and then osteoclast destroys them, and in their place, osteoblast makes the new bone, first of all woven, and then they get lamellized. Now, the steps you need to know. These are the 7 steps that I think Professor Adriana wants, and these are like too detailed. The main ones you need to know these fives, and I explained the difference between the two. The five that you need to know is resting zone, which is here, so it still is a hyaline cartilage. Proliferating zone, which the hyaline or cartilage is in that area, or yeah, hyaline cartilage are getting proliferized, so more hyaline cartilage is being produced. And then they go through a zone of hypertrophy. So the same um, cartilage cells are just getting bigger. They're not dividing anymore. They're just getting bigger. So hypertrophy. And then they're getting classified. And after classification, they go through a process of ossification. Ossification means that they're going to get removed, and in their place, osteoblasts are making new bone. The difference between the right side of the slide and left side of the slide is that between step here, between the classification zone, so here, and the ossification zone, there is this very visible line if you look at your slides, which they call it line of erosion. And after zone of ossification, I already mentioned that, this is just the woven bone. So the woven bone, some part of it needs to get resorbed by the osteoclast, and in their place, osteoblasts try to make the bone lamelarized. So there is another zone called resorption zone. You don't need these 7 zones. These 5 will suffice, but if they want to ask more questions, they will ask about these 2 extra steps. Now, more important info you guys need to know. Bone remodeling, it happens throughout your life. It's a continuous cycle and never ends, okay? And bone growth, guys, for flat bones, for short bones, and for widening or appositional growth of your long bone, there will be intramembranous ossification taking place, especially from periosteum. And for longitudinal growth, or the length of your especially large bones, there will be endochondral ossification taking place through the epiphyseal plate that we talk about. Okay? So that's another thing you need to know. And finally, we get to the very interesting part of bone repair during your fracture. So let's assume that this was your leg, your femur, and you have did some activity, I don't know what, and you have result in a fracture in it. So this fracture will divide these 2 areas of the bone. Now, obviously, there is some arteries in there, so the arteries will just pour into that area and eventually gets hard in that area as well. They will form something called hematoma. Okay? Now, this hematoma in the like about 2 or 3 weeks after the fracture, they will get removed by different they will get removed, and in their place, cartilages gets replaced in that area, collagen fibers. It becomes something called soft callus. And then these soft callus, if there is the periosteum has also get damaged, the periosteum will get formed around these soft calluses as well. And then at about 1 to 4 months after the fracture, these arteries that previously was there, they will penetrate this soft callus and start bringing osteoblast in that area. And osteoblasts obviously go through ossifications and form a woven bone, a primary bone. But later on, at about 4 months or more, till 12 months after the fracture, these woven bone, as we already talked about it, they get replaced and become lamellar bone. So simply the parts that have not been like straight, lamellar, and polar to each other by osteoclasts, they get resorbed, and in a more lamellarized or pallar structures will be formed by osteoblasts. And if the periosteum has not been damaged at the beginning, then this whole process will take even shorter time. So that's the last thing I need to talk about for you guys for bone repair. And thank you for listening to me. I hope you guys enjoyed it. And this is my email. If you had any questions, I'm always available for you guys. Let me stop sharing, and after this, we can end the recording. See you guys.